just before I summarize my demo, so I got a part which is the same part for the Polaris dataset we were discussing throughout this demonstration. And now what I have done here is I also have a mold which is created based on this model, that core and cavity. And also what I have done is I also have an NC core insert NC is being created for that design as well. So they all are linked. Again, if I just come back to my final part, I'm actually working on that. I have not finalized my design. The advantage is here is maybe at the maybe at the second stage of a design, or maybe I just halfway through, I can actually, my designers can take this part, and mold designers can start their design. Once the mold designers have been done half of the core and cavity, somebody can actually order the material and start machining process. Parallelly we can run this. And then, I got this model almost completed. If I just look at the ribs here, I only got the one rib at the moment. And let me quickly run some simulation live analysis and just rerun similar analysis which I have done before. And looking at the von Mises stress here, it is um, around 32 or 33 megapascals. Now what I'm going to do here is, if I do some design changes here, okay, so let me just add another rib, same like what we have done before. I can come back and rerun that analysis again to see that the product quality is going to improve. From 31 megapascal is now the stress concentration distributed between these two ribs from 8 to 18, which is a good thing. But normally, if you're thinking about doing some changes here, for example, maybe some changes here which affects my parting lines. There is a parting line change going to happen here. It's a big problem because if probably they already start design, they say no, we can't change the parting line. It's all done. It's so much work for us to modify the parting line. With the Creo, I can now come back to my mold design. All I need to do is regenerate my assembly. You can see straight away that parting line is being updated. If I just hide the model here, you can see that rib is being updated in my core. Not only that, if I now come back to my um, core inside here where I'm doing all the manufacturing, that also got updated. I previously had a machining done. So what I'm going to do here is just update and Control G, regenerate my model here. And you will see as soon as I do that, it actually update my toolpath as well. You of course need to rerun that toolpath, but you will see in a minute, it will do all those update here. So you got the whole idea of that fully interconnected system. The make model work for you, the theme from PTC here. You do some modeling changes, you validate that inside Creo simulation live, and you update that design straight away into mold design, and from the core and cavity will update and the toolpath will update. Just a couple of minutes, that design changes have been happened. Otherwise, if it's all think about the scenario where it's all third party systems. The designer is taking decisions based on his experience, and he need to do some changes. The model design need to be updated. The model need to be reworked. Everything need to take more time. In order to get past that, information itself will take time. Again, if you got Beanzel data management system, everything will be managed. Whatever I show you today will be managed inside Beanzel as well. That will give you an extra value for you. The designers can grab the model. Manufacturing engineers, designers can grab the same model. They all are connected between one single solution. Okay. All right. So let me summarize my demo. Okay. So that concludes my manufacturing part of the demo. So far, what I show you so far from the beginning of my webinar is the design validation tool, simulation live. Then we went to mold analysis to show the mold simulation and also different options in the manufacturing, including tool design and also CNC. Okay, so you can validate your design with integrated simulations. evaluate the mold for performance, and also you can turn your design into reality using molding and additive manufacturing and NC machining.